Hi everyone, in today's lesson, we're going to talk about what a Van der Graaff generator is and how it works. So the Van der Graaff generator was invented in 1930 by Robert Van der Graaff and was originally used for charging particles and atomic accelerators and is now being used in educating students on how electrostatics work. Now, let's see how the generator works. So the generator features a small motor that makes a roller at the bottom of the machine. Once it starts turning, the roller causes a belt to turn, which then triggers a second roller at the top of the machine to turn. Two metal combs are positioned very close to the belt, one at the top, one at the bottom, and the whole generator is topped off by a large metal sphere. Remember that although all Van der Graaff generators have identical parts, they are not made of the same materials and can work a little differently. However, the relative tendency of materials to lose or hold on to negatively charged electrons is constant. In this generator, the belt is made of cotton, a neutral material, whereas the lower roller is made of Teflon, which is used to attract electrons. And when the roller starts rolling, it rubs against the belt, setting it in motion while creating friction between these two parts. The friction then causes electrons to jump from the cotton to the roller, which become negatively charged. The belt is then left with a positive charge, and this is called the triboelectric effect. Meanwhile, something else is going on in the metal composition just under the roller. Metal is a great conductor of electricity, meaning electrons move very easily through it, and as similar charges repel each other, the large amount of electrons that have built up in the roller repel electrons away from the tips of the metal comb, leaving those comb tips with a positive charge. Now, there is an electric field in the air between the positive comb tips and the negative roller. As a result, electrons in the nearby air molecules break away from those molecules and go to the positive comb tips. They leave behind positively charged molecules for ions, which are then attracted to the negatively charged roller. The positive air ions can't reach the lower, however, because the belt is in the way. Instead, they end up coating the outer surface of the belt and are carried up to the top of the machines. The top roller is made of aluminum, which tends to lose electrons, and as the positively charged belt rubs against it, electrons move from the aluminum to the belt, giving the roller a positively charge. This positively charged roller attracts electrons to the tips of the comb, creating another electric field that once again strips electron from the air molecules that are inside it, but this time towards a positive roller. The positive air ions left behind are attractive to the negative comb tips because the top comb is attached to the metal sphere. These positive charges travel towards the sphere and spread out across it. They will accumulate in the sphere until an object, such as this rounded wand, comes close enough to discharge it. And as the rollers continue to roll, the cycle repeats and goes on. Now that we're done with how it works, let us know the reason of why the hair of an individual who touches the generator rises. As the generator is charging, it transports the charge to the person who is touching it, and since the person's hair is getting charged to the same potential, they try to repel each other, causing the hair to stand up. We have now reached the end of our lesson. I hope you learned something today. And you may also check these links as I use them as references in making this video. See you next time!